So here in linear motion we have mass, and equivalent to that in rotational motion we have moment of inertia. And the formula that we write for kinetic energy here, that is half mv square, and here k is equals to half. Instead of mass I would have inertia I, and instead of linear velocity I would have angular velocity omega square. Okay, now let us read some from the book. Topic 7.20, moment of inertia and its physical significance. According to Newton's first law of motion, every body continues. Those who don't have book, they can just listen. According to Newton's first law of motion, every body continues in its state of rest or uniform linear motion unless an external force acts on it to change that state. The inability of the body to change by itself its state of rest or of linear motion is called inertia. So what is inertia in linear motion? So inertia is the doesn't allow the body to change its state. Similarly, a body rotating about a given axis tends to maintain its state of uniform rotation unless an external torque is applied on it to change that state. So here you have Newton's first law, that if F external is equals to 0, no change in state. Okay, so why there is no change in state? Who doesn't allow this change in state? It is the inertia that doesn't allow change in a state. Similarly here, equivalent to that, we have if tau is equals to 0, of course internal is 0, so if tau external is 0, no change in state, no change in rotational state of rotational motion, no change in state of rotational motion. And why this is due to? This is due to moment of inertia. This is due to moment of inertia. This property of the body, by virtue of which it opposes the torque tending to change its state of rest or of uniform motion about an axis, is called rotational inertia or moment of inertia. Now what is this? How do we calculate this? We know the value of mass already, 7 kg, 3 kg given to us 1 kg. How do we calculate I? So students, we cannot calculate the inertia here because we use mass, but here in rotational motion we use I instead of mass. So mass is replaced by moment of inertia. So we need to know the value of I. That is important. So this is what our topic is all about, finding the moment of inertias of different bodies. Okay, so what is this moment of inertia? So first of all, moment of inertia is of rigid body. The body should be rigid, and it is about you need to mention about the axis, about a fixed axis. So whenever you will be writing the moment of inertia, you have to mention the axis. You have to mention the axis. About which axis you are talking about? The moment of inertia, about which axis? Now what is this? This is the moment of inertia. Suppose you have this body, you can see figure 7.36, or you have this body, rigid body, this is xy plane, x, y, and here we have z. So this is your floor, this is your, you can say this is your wall, then you draw a figure like this. Okay, so this is your floor, this is your wall, and this one is also your wall. So students, assume figures like this. Okay, so this body lies in xy plane, and z-axis is the axis of rotation. Okay, so what is the axis of rotation for this figure? OZ is the axis of rotation of this figure. Okay, now the moment of inertia of this rigid body about a fixed axis is the sum of products of masses of the particles constituting the body and the squares of their respective distance from the axis of rotation. So this body has mass, it has suppose this body is, and it is rotating with angular velocity omega. Okay, so it is rotating with angular velocity omega, and it consists of, suppose, n particles whose masses are m1, m2, and so on. So this, suppose here I have mass m1, and then m2, and then m3, and this body lies in xy plane. Okay, you can, some of the time you draw the figure like this also, that okay, this lies in xy plane, but this is also xy plane. Okay, so mass m1, m2, mn up to mn, and so its distance from origin m1, r1, distance from origin r2. This, suppose m3, distance from origin r3. So distances from axis of rotation, you can say. So distance from axis of rotation. So from axis of rotation. So obviously in xy plane you have point O, origin, which lies on axis of rotation. So distance is from axis of rotation. The distance of m1 is r1, distance of m2 is r2, and so on up to rn. Now the moment of inertia of the body, you can write the axis here also along the z-axis. This is also one of the ways of writing it. So you write here the axis of rotation. So moment of inertia, about how will you read it? Moment of inertia about z-axis. This is how you are going to read it. So that's equals to m1. It is the product of, what is its product of? Product of masses and squares of the respective distance. Squares of the respective distance from the axis of rotation. So r1 square plus m2 r2 square plus so on plus mn rn square. Now suppose okay, if we have only one particle, suppose if we have this particle P, okay, and this particle P has mass m, okay, this particle P has mass m. and it is rotating, you know. So what will be the inertia of this particle P? So there is a particle, this is a particle P, this is a particle P which is at a distance r, and its coordinates are xy. Okay, it is at a distance r, and you know that r square is equals to x square plus y square. Yes, these are your coordinates. Okay, so what is the inertia of moment of inertia of this particle? So this is the moment of inertia of the rigid body we were talking about for the body. Here for particle, how will you write it? For particle P, for particle P, Iz is equals to mr square. So mass of this particle in multiplied by square of the distance from the axis of rotation. So axis of rotation is that. So students, that's how we write so that's how we have written, yes, moment of inertia of particle with mass m1 plus moment of inertia with particle mass m2. So this is a general formula. You can see that for a particle of mass m and distance from the axis is r, so then it is mr square. Now if you add all these, so in you will write them in summation form. Summation I is equals to 1 to n and mi ri square. Okay, so this is what your moment of inertia of the rigid body is, and this is for the particle, and its coordinates I told you xy. So this distance is, so if this is your y-axis, this is your x-axis, so this distance is x and this distance is y, from here to here. This is your y. So students, you can assume this as one of the corners of your room. Okay, so you have to visualize, to understand it properly, or you can assume it as one of the corners of your table, and this body lies and it is rotating about the z-axis. Now the important thing is that what is the dimensional formula for this moment of inertia? So dimensional formula, we write it in terms of mass, length and time. So what's the mass? You can see that there is mass. Yes, there is mass 1. And length, yes, we have length here 2 times a square. And t, there is no t, so that's the dimensional formula of moment of inertia. What are its SI units? So what are its SI units? SI units of mass is kilogram, and for distance it's meter. So kilogram meter square. Okay. Now what is the physical significance of moment of inertia? The mass of a body resists a change in the state of linear motion. It is measure of inertia in linear motion. Similarly, the moment of inertia of a body about an axis of rotation resists a change in its rotational motion. So I resists change in state of rotational motion. So that's what we do. See, like at I told you yesterday also that at power stations we have big flywheels. Okay, So we have big flywheels at power stations. So they are at rest, and when we have excess electricity, we supply them with the excess electric power that we have, and then they start rotating. Okay, now they have the energy. Now when we need the power back, then we use that energy. So bigger the wheel, you can see the formula that it depends on moment of inertia, depends on square of the distances. So we have the spokes over here. That is why in the tires you can see that there are spokes, so that they want the mass to be here, means as away means from the axis of rotation. So more is the mass away from the axis of rotation, more will be your moment of inertia. And similarly in your cars also, in trains also, whatever is moving, so initially means it takes torque to rotate it. And so students, whenever we are talking about rotational motion, we talk about torque. Okay, whenever we talk about linear motion, we talk about force. So even if by some mistake I say force, so ultimately it is the torque which is responsible for the rotational motion. And you know that torque is equals to R cross F. Its magnitude is R perpendicular into F. So this tire, so if it is more massive, then also it is work. So like in car you have no choice, but you like alloy wheels. So in alloy wheels, these spokes are so light, and the mass is over here at the circumference. So so this mass is at a distance. So instead of mass at the center, mass is at a distance. So that is the purpose of flywheel, that in power station it means excess energy supplies to the power wheels, and we take it back from the flywheel. And in cars or trains, so that there is no jerking, smooth drive, because moment of inertia will not allow the sudden change. Okay. So thus the moment of inertia of a body can be regarded as a moment of rotational inertia of the body. The moment of inertia of a body plays the same role in the rotational motion as the mass plays in linear motion. And that is why moment of inertia is called the rotational analog. So students, the word analog here. So rotational analog of mass in a linear motion. Now on what factors moment of inertia depends? The moment of inertia of a body is the measure of manner in which its different parts are distributed at different distances from the axis of rotation. So unlike mass, it is not a fixed quantity, as it depends on the position and orientation. So here in linear motion, the inertia depends on mass. Okay, not on how this mass is so it's a fixed quantity like the mass of the body. But here this inertia is not a fixed quantity like we will do it for the ring. So if you if your axis is over here, so where at how many places you can have your axis? See, this is an xy plane, and this is z axis. This ring, you are rotating the ring along the z axis, and another way is that you bring this z axis here at the tangent, means perpendicular to the it is still in along the z axis, means parallel to z axis. It is still parallel to z axis, students, and it is tangential. Okay, so like these are the four things that is possible. That is on page 7.28, you can see. And then we have along the diameter now. Okay, I'm rotating it along the diameter. So this is one of the diameter. So this is your I'm rotating it along y-axis, you can say, or I'm rotating it along x-axis, you can say. Okay, so along diameter. And now I am rotating it again, bringing it at the tangent. So again bringing it at a tangent. This again parallel to y-axis. So see, these are the four different axes. So here the mass, if we take the kinetic energy, the mass is 2 kg of this ring. So that 2 kg it is fixed 2 kg. Okay, but so m is equals to 2 kg means m is equal to 2 kg. But in case of if we are rotating this body, so it will have different inertia. So inertia, if we are rotating this way, inertia is equals to mr square. If we are rotating it parallel to z-axis, then the which is case C in your book, this is case A. So in case C, you can see that moment of inertia along this tangent is equals to 3 by 2 mr square. And in this case, moment of inertia, which is figure B, moment of inertia along the diameter is half mr square. And when it is parallel to, again, moment of inertia I dash, you can say I dash tangent along the tangent. Here also it is tangential, but it is parallel to y-axis this time, and that's equals to 2 mr square. So students, you can see that if that is why in the beginning I told you, you have to tell which axis you are talking about. So if the axis is different, then your moment of inertia will be different, because moment of inertia, now you have understood, it depends on the distribution of mass. See, here it was the distribution of mass, and here when it was tangential, so the distance means so this is your case B and this is your case D. So in this case, the masses from the here, this mass, see, it is very near to this, but this mass has gone too far away from the axis of rotation. That is why it is 1.5 times, because this mass, this half of the mass, gone so far away from the axis, so it is increases. Okay, and when you are moving it in the plane of, so this was the ring was in xy plane and your axis of rotation is in y plane, so it has reduced to half mr square. But now it's so difficult, it has the maximum moment of inertia. Why maximum? Because you have to rotate this ring, it is in xy plane, and assume it that you are rotating it this tangentially parallel to the y-axis. So this has maximum moment of inertia, 2 mr square. So twice even from this. So students, now you have understood that this moment.
Excuse me, sir.
Yes.
Sir, in C and D figure, our circular body will rotate.
Yes. How?
Sir,
In C and D figure, yes.
our circular body will rotate. वो तो सर रोटेट ही नहीं कर पाएगी.
See, this whole body will rotate. See, this is the axis of rotation. This is the axis of rotation, and this ring is rotating around this axis. This whole ring. Here it was rotating at its own position. It was rotating here at its own position, this ring. Okay? But here the ring is changing its position when it is moving around z-axis. That is why moment of inertia is also more. Have you understood? Here it was rotating at its in the circle. Okay? All the ring was rotating in the circle. So this, see the position of like this is mass m1. Okay, and then the mass m1 will reach here, then the mass m1 will reach here, then the mass m1 will reach here. Yes, it is rotating like yes, it will move like this. Yes, and here this is suppose mass m1, so it will move like this. It will move like this. This mass m1 will come here, and then here. If you see it in top view, where will this mass? It will be moving in front of you here, and then it will be moving from here to here, then here to here, and then here to here. This is just like your hinge. This is your door. This is your circular door. Okay, now you have understood. Yes.
Yes, sir.
And here also you can assume this as hinge, and this is your door. So here you are moving this door. Assume that some of the time, like if this axis is, along the y-axis, then how difficult it is to move this, rotate this door. Okay. So here in case A and B, they are, the masses, they are here also it is here it is horizontal motion. Here it is means horizontally it is moving at its place. Here it is moving at its place vertically. No. So students, have you understood these figures?
Excuse me, sir.
Yes.
So figure C and D, they are not similar.
See, how can they are not similar? Because here the your ring is in xy plane. Okay, and your axis is z axis. Means axis of rotation is z axis. This ring lies on floor. This ring lies on floor in xy plane, and you are simply rotating it on the floor, this ring.
So, but if we compare both the figures, then the plane and the axis, rotation of axis, both are perpendicular to each other. Because in D figure also the axis is y and the plane is xz. So it's just the
See,
virtue of
there
position, na?
the axis is in the plane of the ring. Here the axis is perpendicular to the plane containing the ring. So of course these are two different cases. You can try it out. You hold a pencil horizontally in figure D. Hold a pencil horizontally and move your whole ring around it, and then hold your pencil vertically and move your ring around that pencil. So here in figure C you are holding the pencil vertically and you are moving the ring around it. Ring is horizontal and your axis is vertical. Okay, but in figure D your axis is horizontal. Okay, so which is in the plane of the ring. Okay,
Yes, sir.
now so moment of inertia depends on mass of the body, size and shape of the body, distribution of mass about the axis of rotation, and the position and orientation of the axis of rotation with respect to the body. Now what are some applications, page 7.26, what are some applications of use of moment of inertia? So if we talk about the applications, first application, a heavy wheel. So what is a flywheel? Flywheel is a heavy wheel which is attached to the shaft of a steam engine. So like we have this is the shaft and this is how it is attached with this shaft. This are the spokes. Okay, so you can assume this figure, no problem, right? So it is attached to the shaft of the steam engine or automobile engine, and because of large moment of inertia, flywheel opposes. So flywheel, which is quite heavy, opposes the sudden increase, decrease or increase of the speed of the vehicle. Okay, and prevents jerky motion and avoid jerky motion, and you will get as a result smooth ride. Okay, now in case of bicycle or bullock cart, the moment of inertia is increased by concentrating most of the mass at the rim of the wheel, that we have already discussed, and connecting the rim to the axle through the spokes. Even after we stop pedaling, the wheels of a bicycle continue to rotate for some time due to large moment of inertia. Now we did it yesterday also. Relation between 7.21, relation between rotational kinetic energy and moment of inertia. So we have masses m1, m2 up to mn, and particles. The body consists of these masses, and they are at a distance r1, r2, r1 from the axis of rotation. Now what will be their linear velocity? All of you know that their angular velocity is same for all of them in rotational motion. And what is linear velocity? That is equals to r omega, and so it is always v is equals to, I told you that it is omega cross r, but we write v is equals to r omega because r is constant radius, and angular velocity you can also write it omega r, that's your choice. So what will be the linear velocity of this particle whose mass is m1? So its linear velocity is v1, and that is equals to r1 omega, and its linear velocity of m2 is v2, that is equals to r2 omega, and so on. Now what about the kinetic energy of the of this body, this mass, kinetic energy of this mass? So kinetic energy of this mass will be half m1 v1 square. What is the kinetic energy of this mass? It is equals to half m2 v2 square, and plus so on. Now what will the kinetic energy of the whole body? So kinetic energy is a scalar quantity. We can simply add, and adding all these quantity will get, you can see that, put the value of v1 equals to r1 omega over here. So we get half m1 r1 square omega 1 square plus half m2 r2 square omega square plus so on. Okay, so this is not omega 1, this is omega only. Yes, because omega is same for all the particles. So that we can write as summation. Now take the constants outside. What the constant quantity? We have half constant, and we have omega square is also constant. So omega square is also constant. So what we are left with? See, the variables we are supposed to change. So m is same. Okay. R is also same. Okay. Square. So this square is also same. But here I have 1, I have 2. So the variable quantities I represent with I. That is how we write. Now m1, m2, r1, r2. So here also this 1 and 1, this is same. Okay, so that is why we have I. If suppose if it is m1 r2 somehow, not this formula, I'm talking about some, like if this is a1 b2 cube plus a2 b3 cube plus a3 b4 cube, then how you are going to write it? You have to write it summation. What are the same things? A is there, same. B same. Now this cube same. But what is changing? Here it is changing from 1 to 2 and then 2 to 3. So I will be writing here I. Now is this I and I, are they same? No, this is plus 1. So I will write here I plus 1. So that's how we write summation, friends. Okay. Now this is I can also write it as half summation mi square. Okay, so put it in bracket. Summation is only from here to here, and then omega square. That's not the part of this summation. We can write it like this also. Okay, now comparing it with the kinetic energy in linear motion. So this is the kinetic energy you have here. So K is equals to this. So kinetic energy in linear motion is half mv square. So you can see that this thing is the analog of mass. So that is I. And this is square of angular velocity. This is here linear velocity. So that's I equals to sigma mi ri square. So I is equals to sigma mi ri square. Okay. Now this is the rotational kinetic energy that we have. So how do we write it? So rotational kinetic energy is equals to half I omega square. And here in linear motion, linear kinetic energy was this. Now students, one more thing here. How to write definitions. This is another very important how to write definitions. Another way of writing the definitions. Very important way. Like kinetic energy is equals to half I omega square. Okay. And when when omega is equals to 1, when omega angular velocity is equals to 1, then this rotational kinetic energy will be equals to half into moment of inertia into 1 square is 1. So and I is equals to twice of kinetic energy. So condition, when omega is equals to 1, then I is equals to 2k. So you have got the definition of moment of inertia from here also. So you can write it as moment of inertia of a rigid body about an axis of rotation is numerically equals to twice the rotational kinetic energy. See, you are writing it like this, but like moment of inertia of a rigid body about an axis of rotation. This is how you are writing it. Is equals to twice the kinetic energy of the body. When you have to write the condition here. When students, you need to deal with these kind of definitions more and more in class 12. So in class 12 you will have see, whatever we are teaching you in class 11, we are preparing you for class 12 and means for higher classes. Okay. So there is a purpose of the teacher of all the subjects that the teachers are teaching you. Physics, chemistry, math. They know what you are going to learn in higher classes. So we are preparing you for higher classes. Okay. So keep this thing in mind. So step by step, we are moving up. And we are equipping you with the tools that will be required to study physics in the higher classes. So we are moving step by step, first thing, and second thing, we are equipping you with the tools. Equipping you with the means giving you the tools, you can say. So giving you the tools, especially so that tools like ABCD of the language. So this is one of the very important way. You will deal with it in class 12 also, I told you. So understood, write the formula and then writing when this is a special case. So you have to write it. So I is not equal to K all the time. No, it is equal to K when. So whose moment of, so of course moment of inertia of the rigid body you are talking about. So when the body is rotating, when body is rotating with unit angular velocity about the axis. So angular velocity is also about the axis. So this is the thing that you need to write. So this is also definition of moment of inertia. So one definition we did earlier. This is one definition. This is second definition. So second definition is not only this whole. So this was definition 1. This is definition 2. So numerically equals, this is the thing that is written over here. Okay, now we have another term which is radius of gyration. So what is radius of gyration? So students, after doing it from here, you have to do it from you have to read these topics from NCERT also. So radius of gyration. So for any body capable of rotation about a given axis, it is possible to find the radial distance from the axis where if the whole mass of the body is concentrated. The moment of inertia will remain unchanged. This radial distance is called radius of gyration and is denoted by this small k, because capital K is for the kinetic energy. The radius of gyration of a body about its axis of rotation may be defined as the distance from the axis of rotation at which if the whole mass of the body is concentrated. See what it is telling you. This is your axis of rotation. So radius of gyration, of course, it is of a body. First thing. And second thing, it is about the axis of rotation. So these things you need to add on. At which if the whole mass of the body were concentrated, its moment of inertia about the given axis would be the same as with the actual mass of distribution. So I equals to mr square. This is the formula that we have studied. Mass m, and that mass is at a distance r, and the formula for means you can write it in the form of m k square also. Okay, m k square. Let me just tell it to you, you will understand it more. See what was the I for in case of ring. We did 4 cases. Like in case A, I along the z-axis, that was mr square. So here this I you can write it in terms of k, m. So the standard form is I is equals to mk square. So what is k here? So k is equals to r. Second, then you find along the diameter, that was along xy plane, and that's equals to mr square by 2. So here in this case, what is your k? So value of k is equals to, tell me what is value of k? This is k square. This is your k square. What is k then? R upon under the root 2. Okay, R upon under the root. C case. Now moment of inertia along the tangent you found. That is what 3 by 2 mr square. Now first of all you have to so mk square. So this here your k square is this. So what is the value of k? Value of k is under the root 3 by 2 r. Okay. Now d case. You are taking the tangent parallel to x-axis here, parallel to z-axis, this tangent, and that was 2mr square. So m into 2r square. So that's your k square. So what's k equals to? K equals to root 2r. So students, you have understood. So for all the we are writing the this is third form of writing moment of inertia. Another way of writing the moment of inertia. If you are assuming the whole body, so this is capital M, so this is also capital M. So assuming the whole body, the whole mass is concentrated. So as if the whole mass of the body were concentrated, okay, and the moment of inertia, its moment of inertia about the given axis would be the same with the actual distribution of mass. So what does this mean? This means that you have the extended body over here and you calculated the moment of inertia of this body. So it's telling you, assume that the whole mass of the body is concentrated at this point, and this is at a distance k, okay, from the axis of rotation. So the whole mass, so here the mass was m1, m2 and so on, lot of particles and particles, but here the mass is concentrated at one point, okay. So moment of inertia is and this distance is your k, okay. So what will be the moment of inertia? I is equals to mass of this particle into its distance from the axis, so that is equals to, so here r has become your k. So that is the meaning of radius of gyration, okay. So I is equals to mk square. Assume the whole mass of the body is concentrated at this point, at this particle, and the moment of inertia about the fixed axis will be the same. So I is equals to mk square. I hope students this is clear to you. So it's a geometric property, this radius of gyration, geometric property of the body and axis of rotation, and it gives a measure of the manner in which mass of the rotating body is distributed with respect to the axis of rotation. So you can see that the units of k is length, so it is measured in same as r, its length. Now let us find the expression for k. So we have a rigid body which consists of mass m1, m2 and this distance. So what will be the moment of inertia of the body? We are considering these all masses are equal, okay. We divided the body such that all the masses are equal. So what will the moment of inertia? mr1 square, inertia of the first mass, and then the inertia of the second mass, mr2 square, and so on. And that's equals to, m is the common here, and now along with that this is r1 square plus r2 square plus so on. Now I'm multiplying it with n and dividing it with n, okay. I can do this, okay, it's the same thing. Now this is equals to this, what is this, m into n, because I want to bring here capital M. How can I bring capital M here? So the only way to bring capital M is that multiplying it with, so there are n masses, m r n square. So n masses, so multiplying this m with n, right? So you'll get the mass of the whole body. So this is what I needed. So this is how to derive the formula. I know that this formula is mk square, so how to bring here? So I need to multiply it with n. So if I multiply it with n to bring this capital M, I need to divide it with n also, so that this will be equals to this. Now this is your k. This thing is your k. This is your k, and this is your m. This is k square. Okay, so now what is k? K is equals to under the root r1 square plus r2 square plus r3 square and so on up to rn square divided by n. Very important concept, students. How shall I write it? So k is radius of gyration of a body about an axis of rotation, is defined as the, what is it? This is root mean square. Root mean square, RMS. Whose root mean square? Root mean square of the distance. RMS of the distance of its particles from axis. Axis of rotation. So students, this is a term that you will be frequently dealing in physics. In class 12 also you will be dealing with it, root mean square. So let us write it again. Root mean square distance. So this is noun here. These three are adjectives. Okay, so start from distance. This is my distance. Okay, first thing. Second thing is, you have to distance means root mean square distance of its particles. So I have taken the distance. Okay, now square this distance. Okay, I have squared this distance. Now finding the first thing you have done is square. Second thing, you need to do the mean. So r1 square, r2 square, r3 square plus so on up to rn square, mean divided by n. So there are n values. Okay, so you can write it as mean square also. This is the mean square of the but the standard notation is mean squared. So you have mean squared means first you have squared and then you have found the mean of it, and then root of it. So this is the first step, distance, then second squares of the distance, and then third finding the mean, and then the fourth thing is the root. So this r is root mean squared. So that's how we write it, root mean square. Okay, now you clearly see that on which factors radius of gyration depends. Now students, the next topics, theorem of parallel and perpendicular axis. That's not the part of syllabus this year in class 11. The syllabus is reduced, but these are very important theorems. You can do it from SL Arora. The derivation is also given. Those who are interested in giving NEET and IIT, they need to do these theorems, of course, because to find the moment of inertia, we need these theorems. So what is this theorem of perpendicular axis? So the theorem of perpendicular axis, we have I told you the body in xy plane, and this is I have told you this diagram. There is a particle P, and this its coordinates xy. So, and this distance is your r, and this distance is your clearly y. This distance is this x-axis, clearly x, and this is z-axis. So the moment of inertia of the particle about x-axis. So moment of inertia of the particle about x-axis, if I'm talking about, that is equals to, so about x-axis. So where will be your center? About x-axis you are rotating. So the particles, this particle will be at a distance. What distance? If you are taking axis, so it will be at distance y. Yes. If the particle P is rotating around x-axis, so what will be its moment of inertia? Small m is the mass of the particle, and it is at a distance y from the x-axis, right? Now moment of inertia of the whole lamina. Okay, so this was of the particle, and this particle, so you can write two things. One is where is the, from which you are taking the distances from B. This y is from B, and second thing is it is in YZ plane, the body is moving. Okay, so this is point B, you can write here, this is point A. So axis is through B. Okay, axis is through point B, and the body is rotating in YZ plane. So now you can simply write this for the whole body. So see, that's the problem, you cannot write ix again. So I can write it this I dash x, and for the whole body I will write it as x. For the whole body, this will be the summation of my square along the x-axis, and similarly along the y-axis the moment of inertia will be mx square. Now moment of inertia along the z-axis, you know what is it, you have calculated it, that is what is the distance now. So here the distance is r. This is the distance of this point P. So when you are moving it along x-axis, its distance was y. When you are moving it along y-axis, its distance from the y-axis was x. Now you are moving it along the z-axis, its distance from the z-axis is r. You know that r square is equals to x square plus y square. So this is its distance from x-axis, this is its distance from y-axis, and this is its distance from z-axis, distance of the particle P from the axis. So we can write it as sigma m r square. Okay, and now put the value of r here. R is equals to x square plus y square plus z square. So iz is, so this is equation 1 and 2. So this is equation 3. So sigma m x square plus y square using 3, and so iz is equals to sigma m x square plus sigma m y square, and iz is equals to, what is this? This is I y plus this is I x. So using first and second. So this is the theorem of perpendicular axis. Similarly, you can do the theorem for parallel axis also. So the point is that here these two axes are in one plane, and we are finding, if we know these two inertias, so we can find the inertia for the perpendicular axis. Okay, so inertia for the perpendicular axis we can find, and here theorem of parallel axis. So now we know the moment of inertia about this axis, and we have now I want to know the moment of inertia of this axis. So this axis is at a distance d. Okay, so this rs and this is pq, and we have a particle over here whose mass is m, and it is at a distance x. So in your book this distance instead of d, they have taken this distance as a in your. So that's the problem, in NCERT, and there are little bit they have changed the variables. So in SLR you have d here, this distance, and in NCERT you have a. So that's your choice, you want to take a or d. So but my preference is always remember the formula as per NCERT only. Understand it from any book, but formula, variables according to NCERT only is my preference. But you need to have, means you are supposed to be comfortable with D also and with A also, because in your entrance exams there can be, they change the variables to get the students confused. They change it with R also some of the time. Okay, so that is why you need to be comfortable with all the variables, but formula remember in one way, that is the variables as per NCERT. So here this distance is d, and moment of inertia means of the particle about the axis pq. So that will be, this mass is small m of the particle, which is at this point p. So this is mr square. So m into, and what is the distance here? Distance is we are taking d as per SLR. So this distance is x plus t. So m into x plus, so mr square, that is the inertia. So mr square, r is x plus d here. So square of it. Now moment of inertia of the whole body about the, so this was of particle, so you can write it as I dash, and then this is for the whole body. So that's the summation m x plus d whole square. Now that's equals to summation mx square plus summation md square plus summation 2mxd. And so what is this value? Mx square. Mx square is your inertia of the whole body about center of mass. Yes, that's the formula. We have the inertia about the center of mass. And what is this md square? So d is constant, d will be outside, and we will be taking the summation of mass. Summation of mass is capital M, so that is capital md square. And now 2d is constant, and we are left with summation mx. So 2d is constant, and we are left with summation mx. So what is summation mx? Summation mx will be 0. Okay, so how it is 0? So look at figure. Look at figure 7.24 in your NCERT. Figure 7.24 NCERT. Okay, so how this is 0? Because you know that when you are balancing a cardboard, okay, your means then summation when you are rotating it, so just like you have the figure 7.24, you can assume this, that these distances are, if it is means this MIRI, this distances, shall we take 7.24 figure, because rotation means this is net tau is equals to summation mi ri cross mig, yes, and that's equals to 0. So that's equals to 0 means when you are balancing it, so g is constant, so it means mi ri is equals to 0. Okay, so that we are using here, that mixi, because this mx means sigma mixi, and you can further write it as, because this is your center of gravity. So if you are holding this body at center of gravity, so that is the point which is center of gravity, where the body is pulled by the where you have gravitational force. Gravitational force is acting. So mi sigma mi ri is 0, and here mi is your ri is your x, so sigma mi xi is 0, and that is why this sigma mx is equals to 0. So this term will be cancelled out, so you are left with moment of inertia is equals to moment of inertia around center of mass plus mass of the body into distance d. So students, next topic is moment of inertia of the thin circular disk. Let me tell you just last 2 minutes. Your A part, you have derived the formula like I is equals to mr square, means this along the z-axis. Now in part B you have derived the formula, means how will you find it along one of the diameters. So you can see that this diameter is perpendicular to this axis. This was z-axis, and this diameter is along xy plane. So so you can use the theorem of perpendicular axis. So this is the theorem of perpendicular axis, so you can use it. So this z, you can find this iz is given to you, you have found it over here, and this iz is equals to, so this along the diameter you are finding, so this is like ix, and this is iy, they will be same by symmetry. So iz is equals to ix plus iy, right? So this you know this is mr square, and these two are same, so that is twice of ix you can write, and along the diameter, that is your ix, or that is equals to mr square by 2. So you have derived the formula, you need not to derive it. So here you use the calculus to derive A, but to derive B you can simply derive it using the perpendicular axis. So, and same formula C you have derived like along the tangent you want to find, so you can find it using the theorem of parallel axis, and then along the tangent perpendicular to the plane, again you can use the theorem of parallel axis. So that is why only A formula you used calculus, and B, C, D you used for, so that's how we use the theorem of perpendicular and parallel axis. So students, you have the table in your book, that is table 7.1 in your book. Okay, so write these formulas in your notebook from the table 7.1. that is part of your syllabus. Okay students, that's all for today. Thank you so much for being with me.